Hi everyone, in this video lesson we are going to speak about virtual local area networks, VLANs. First of all, to understand what is the VLANs, we have to take a look for a small example in which we may find out that our equipments PC0 with laptop 1 are connected to single network. So they are part of the network 192.168.10.0 with prefix 24. So we may see that they are in single network. So, and if we'll take a look for PC1 and PC2, we may understand that they are connected to a network. So let me write here 192.168.20 with prefix 24, and laptop 0 with laptop 2 are connected to network 192.168 and series 0 with prefix 24. So actually, if I'll ask you what kind of communications is possible between these equipments, maybe some of you will say that, alright, so PC0 is only able to communicate with laptop 1, and laptop 0 is able to communicate with only laptop 0 is able to communicate with laptop 2 only. Well, actually it is somehow correct, but we may have such kind of situation that so as you see here, we have division, logical division by IP addressing, but in case when one of our equipment will generate the broadcast communication, so that if for example laptop 0 will generate the broadcast, so this broadcast packet will go to the switch, and when it will go to switch, it will be the frame. So in the source MAC address we'll see MAC address of laptop 0, and in destination MAC address we'll see MAC address which is looking like the broadcast, so that the switch will receive this broadcast communication and will resend it to all equipments, so that as you see that we have laptop 0 which is on the same network address, IP address network as laptop 2 only, but laptop 0 is able to send information to PC1 and to all other equipments if it is the broadcast communication. So the idea of the virtual local area networks is to distinguish network, single local area network, into some logical divisions, and it is done by creating virtual local area networks, I mean VLANs, and assigning them to the different ports. Let me tell you that we have a standard VLANs numbers starting from 1 to 1005, and VLAN number 1 is default VLAN for all ports on the switch if it is Ethernet connection. And if you will type the command show VLAN brief, or maybe without brief, you may find out that you have a table in which you have in first column description that which the number of the VLAN is. Afterward, you may find out the name of that VLAN. You may find it the status that it is active, and you may find out the ports which belong to that VLAN number 1. For example, we have VLAN number 1, it is default VLAN, and all ports of our switch belong to that VLAN, because it is default VLAN for the Ethernet ports. Well, we have other VLANs starting from 10.02 till 10.05. They are also default VLANs, but they are used for different types of the protocols or different standards like FDDI, token ring, FDDI default, and TRNet default. So we don't care about this names of this default VLANs, but we have to know that by default on Cisco Catalyst switches, we have 5 VLANs which are generated, generated by default, and which are not editable. You cannot delete them and you cannot rename them. Well, and now let's take a look, for example, of how our network will work without VLANs and how our network will work with VLANs. So I prepared for you the small topology in the packet tracer, in which we have the same topology, and here we have to select in the filtration ARP protocol and ICMP protocol. So I select ICMP to see how my ping will work, and I'm selecting the ARP protocol to take a look how ARP broadcast messages will travel through this switch 0. Well, let me take a look for the ARP table of PC0. So I have to type ARP A command, and I see that there is no entry found in the ARP table, so that in case if I'll try to make a ping from PC0 to laptop 1, PC0 will search for MAC address of laptop 1, and when it will search for the MAC address of laptop 1, it will send the broadcast to switch. And as you see here, our PC0 and PC1, they are on different networks, because here we have 10 and here we have 20, but PC1 will receive the broadcast. So let's take a look for this process. So I have to type the command ping, and let me type the IP address of my neighbor 10 and 11. After I pressed enter, ICMP message generated, and this is our ping message. But before our computer will be able to send this ping message, it have to find out the MAC address of laptop 1. And due to that fact that we are on single local area network, our computer will generate the broadcast. When broadcast comes to switch 0 is just resending this broadcast to all other equipments, as you see, and all of them will deny this request, ARP broadcast request, and only laptop 1 will send the message back. And after what we have continue of our process, this is the ping message. It comes to laptop 1, and laptop 1 sends the information to PC0. And if we'll take a look for a laptop for PC0, we may find out reply came. Well, to mitigate, to prevent this unneeded broadcasts for other equipments which are placed on different logical area, or we may say which are configured with different network addresses, and we have to make configurations of the VLANs on our switch, so that we have to go to switch 0. Let me firstly show you that we have VLAN number 1, which is by default configured, which is by default on switch, on the catalyst switch. So we have to type command show VLAN, and after what we may find out this table that we have VLAN number 1, and all ports of our switch belong to this VLAN. If they are Ethernet ports, and we have other 4 VLANs which are created by default, which are not editable. So that our idea is to create new VLANs. So let us say that we'll have with you 3 more VLANs, and they are going to be VLAN number 10. As you see, we'll just create our VLANs, and their IDs will be close to this IP addresses 10, 20, and 30. So let me create VLANs. How can I create VLAN? I have to go to global configuration mode, and in global configuration mode I have to type command VLAN, and then I have to type an ID. For example, it's going to be 10, and then I have to create the name. So for example, name can be department A, and let me create a VLAN number 20, and let me say that VLAN number 20 will have name department B. And now let me take a look. Do I have did I create this VLAN? Show VLAN. And here I can see that I have two VLANs, VLAN number 10 and VLAN number 20, and we have their names. In case if you type VLAN number 30, for example, and if you will not give the name for this VLAN, and if you'll take a look for your VLAN information table, then you will see that VLAN 30 is created, but the name is going to be as default VLAN and its ID like 0030. So I can rename this VLAN like department C. Do show VLAN. Now we can have we can see three VLANs which are created in our VLAN table, and we will assign a proper interfaces to those VLANs. Our interface FA01 and interface FA04 will work with VLAN number 10, so that we have to penetrate into configuration of two interfaces. We can make it with the command of the range, interface range FA01, and interface FA04. And then we'll say that switch port mode access. So we type the command switch port mode access to define that these two ports are going to work with single VLAN. And then we type information switch port access VLAN, and we have to define the ID, for example 10. And then interface FA0, interface range FA02 and FA05, switch port mode access, switch port access VLAN 20, interface range FA03, FA06, switch port mode access, switch port access VLAN 30. And then I have to check my table of the VLANs, and I have to be sure that I configured my VLANs properly. And now we can see that we have department A VLAN, or it is VLAN number 10, which has to which FA01 and FA04 ports belong. And we have interface, we have VLAN 20, and so let me just resize it, sorry. And for VLAN 20 we have FA02 and FA05 ports, and VLAN 30 got two ports, FA03 and FA06. And now we'll try to make the same operation which I did before. So I have in my filter of the protocols ARP and ICMP, and let me clear my ARP table, ARP-D and ARP-A. So now I have empty ARP table, and when I'll try to make ping again from PC0 to laptop 1, my computer will generate ARP request. So this ARP request will go to switch, and as you know, this is the broadcast request, and switch will resend this information only to member of VLAN number 10, and as you see. And then we have reply from laptop to PC0, and then we have ICMP communication. This is our ping. And if we'll take a look for the ARP process of PC1, which is placed on VLAN number 20, we'll take a look first of all to ARP-A, and then we'll make ping to 192.168.20.11. This is our neighbor. So, and as you see, again, ARP broadcast request is generated, and it is directed to switch, and switch just resent only to port FA05 due to that fact that FA02 and FA05 ports belong to single VLAN, and other ports belong to different VLANs. This is how we can use VLANs to separate our network, to divide our network, single local area network, into the multiple virtual local area networks on the second layer, on data link layer, in which we have a function of MAC addresses. Let's continue with our lecture. When we are connecting switches between each other, we have to connect a lot of cables. So if you have here the part of VLAN 10, this is VLAN 20, this is VLAN 30, and this computer belongs to VLAN 10, 20, and 30, for example. So here we have connectivity, so FA01 port belongs to VLAN 10. And here we have port, I don't see exactly which port it is, but let me say that this port is FA07, which belongs also to VLAN 10. Also, we have to connect another port, for example, FA08, which will belong to VLAN 20, and another port will be, for example, FA09, it will belong to VLAN 30. So that when our PC0 will try to make communication with PC10, information has to travel by using this link, and then by using port FA07, it will penetrate to this port, and afterward we'll have such kind of communication. And also, if PC0 will try to make communication with laptop 11, the communication will travel between switches in the same way, and afterward it will be redirected to port FA04. And when another computers from different VLANs, for example PC1, will try to make communication with PC11, its communication will travel through port FA08 in the middle, and will be delivered to copy of the switch 0, and will travel to this computer. So that if you have communication, if you have VLAN connection between two switches, then you have to create so many links between switches of how much you have your VLANs. If you have 3 VLANs, then it will be 3 links. If you have 10 VLANs, then you have to make 10 VLANs links. For each VLAN, you have to create a separate link. And due to that fact that it's not always possible to have so many links, free links between switches. So for example, imagine that you have 15 VLANs on your switches, so that it means that you have to have 15 links here, 15 links. And it's not always possible due to that fact that your switch ports are limited. And that is why it will be better to use such kind of link which is able to provide the communication between multiple VLANs. And this type of the link will be called the trunk. So that we have here port FA024, and we'll configure it as so we'll firstly go to interface FA024, and we'll type the command switch port mode. So before we typed with you access, and now we'll type with you command trunk. And when you type this command, if you type it on the both sides of your link, then you will have a trunk. If you have configured trunk, by default trunk allows all VLANs which are available. Okay, so that if you have 3 VLANs, all 3 VLANs data can travel between these switches. If you have for example 100 VLANs, then all 100 VLANs will be able to send this and receive the information through this trunk link. But also you can make the filtration of this allowed VLANs. So you can just say that allow only 3 of them or allow only a couple of them. So let me show you an example on which we have such kind of situation. Well, firstly I have to check what kind of configuration do I have in this lab. So I think that nothing is changed here from default, so that I have to create 3 VLANs on each of these switches, so that it will be better if I'll open the notepad, and from notepad I will type the command like this: VLAN 10, VLAN 20, VLAN 30, and then I'll type the command interface range FA01 and FA04, switch port mode access, switch port access VLAN 10, and then I'll just copy this part and I'll just paste it here and paste it one more time. Then I have to just change my port numbers, and I have to change VLAN ID. So I recommend you guys to do the same during your laboratory works to be able to submit labs on time and sorry. And then I have to just copy this part and I have to paste this configuration into the global configuration mode of the switch by using paste button. And then I think that I have the same ports and same situation on switch number 2, so I'll just change its host name to S2 to be able to distinguish these two switches during the configuration, and I'll also change it on switch number 1, host S1. And now guys, I'll just type the command do show VLAN to see that my VLANs are created and they are properly assigned, so the ports properly assigned to the proper VLANs. And I know that I have default names, but it's not the problem for me in this situation. And now let's make configuration of the trunk between switches. I have to go to interface FA024 and I have to say that switch port mode trunk. And let me go to the copy of the switch. It's going to be our switch 2, and let me say also interface FA024 switch port mode trunk. And now if I'll type the command show VLAN, I'll see here that my port number 24 is not in the list of any VLANs. As you see now I have, so this is the end of FA0 ports. FA024 is not here. It means that this port is the trunk port. Show interface trunk command will show me which ports are working as a trunk. So, and I have here the port number 24, which is working with encapsulation 802.1q and which is on trunking. So we'll speak about native VLAN and encapsulation 802.1q a little bit later today. And also I want to mention that port FA024 allows VLANs from 1 to 1005. It is by default. And also we have information VLANs allowed and active in management domain are VLAN number 1, 10, 20 and 30. It means that this port as a trunk port allows to communicate to all VLANs from 1 to 1005, but currently it is working only with 4 VLANs. VLAN number 1, it is default VLAN, and also we have created 3 VLANs more. And if we want to change our configuration of the trunk so that it will allow only 3 VLANs, so that we have to go to configure our interface FA024, and we have to say switch port trunk, and then we have allowed VLANs, and we can type here for example all except none, remove, add, or something like this. So we can type VLAN 10 and then VLAN 20 and VLAN 30. Oh, so this say that I have mistake in my configuration. VLAN 10, VLAN 20. So you see this marker say that it's not possible to type here the comma. I think that, so let's try to type like this, 20. Oh, it's not giving us ability to do it. So that let's try to then add another VLAN, for example VLAN 20, and the same VLAN 30. So that we allowed VLAN 10, 20, and 30, and if we'll take a look for our interface trunk configuration, we may see that only 20, 10, 20, and 30 VLANs are allowed. We don't have here VLAN number 1 and other VLANs. And then also let's take a look what kind of configuration do we have on switch number 1, or I'm sorry, on switch number 2. Do show interface trunk command will help us, and on this side we have not changed trunk with allow command, so that is why it is allowing all the VLANs. But due to that fact that our switch 1 is allowing only for VLANs 10, 20, and 30, it means that the traffic of VLAN 1 and other VLANs will not be able to pass, even if on one side it is allowed, for example VLAN 1, but on another side it is not allowed. The communication, if it is not allowed on both sides, it will not be able to pass through this trunk link. And now let me show you one thing. When you have configured your trunk between switches, your communication travels with some changes. For example, when PC 0 is sending information to laptop 1, PC 0 doesn't know that it is placed on any VLAN, and in the frame, so if it is frame, we have source MAC address, and there will be the MAC address of PC 0, and destination MAC address is going to be the MAC address of the laptop 1. So this frame will be generated by PC 0, it will be sent to switch 0, and switch 0 will resend it in the same view. But in case when this PC 0 will try to make communication with PC 10, let me change here will be the MAC address of PC 10. This frame will be sent to switch 1, and then switch 1 has to send it by using the common link, by using the trunk. And by using this trunk, there can be traveled any kind of the frame, I mean there can be travel frame from any VLAN. So that is why when we are sending this frame by using the trunk link, we have to change this frame. So this will be same frame, source MAC address, PC0 with destination MAC address, PC10. But additionally to this frame, we will add a tag. So this is going to be called tag, and inside this tag we have main information. It is VLAN ID. So there will be information that this is VLAN 10 information, so that when switch 2 will receive this tagged frame, it will understand that it has to send the information to VLAN 10 frame, to VLAN 10 port, so that it will be recognized, this frame will be recognized as the part of VLAN 10, and then our switch 2 will delete this part and will resend it to PC10. But you have to understand that every VLAN communication through the trunk have to be tagged. For example, PC2 sends information to PC12. Then it is generating the frame. When this frame will be delivered by the switch, and when the switch will send it to another switch by using the trunk link, this frame will be tagged with additional information, which is going to be VLAN ID, which is going to be now 20, so that when switch 2 delivers this frame, it will be able to distinguish, it will be able to understand from which VLAN this frame is coming, and then it will resend it to this port, to PC12. This is how our switches are making a tagging process, so that this frame is called untagged frame, and frames between switches, if it is trunk link, they are called tagged frames. But we have one VLAN which can be untagged even on the trunk link. For example, let me choose this color. For example, we may make configuration of our VLAN 30. So let me write here. For example, VLAN 30 will be called as the native VLAN. So this configuration have to be done on both ports of our trunk link, so that if we configured our frame, I mean VLAN 30 as the native VLAN, and if laptop 2 will generate the frame, and this information will be sent to laptop 10, for example, firstly it will reach the switch 1, and then switch 1 will resend this frame. Let me delete previous frames. Switch 1 will resend the same frame without any tag which is defining the VLAN, and this frame will come to switch number 2. If we configured our VLAN 30 as a native VLAN, then our switch 2 will understand that this frame is coming from VLAN number 30, and this information will be known without tag. So that when you configure your switch port, your trunk switch port as the native VLAN, you have to be sure that you have configured both of your ports of the single trunk link with the same native VLAN, due to that fact that if you will configure one switch port as native VLAN 30 and another one as native VLAN, for example 10, and when it will send information and it think that this is VLAN 30, but the next switch will think that this is VLAN 10. So you will have some problems in the communication between these VLANs. Well, in which cases you have to use the native VLAN. As you see, we have advantages of the native VLAN due to that fact that native VLANs doesn't have to be toggled. And when you toggle your frame, it means that it is size is growing up and your communication is becoming slower. So the native VLAN can be used in the sending of very important information like a voice. So when you have an IP telephony, it will be better to place your IP telephony as a native VLAN. And now let me show you how to change the native VLAN on your switch port. But before, I'll show you that the native VLAN by default is VLAN number 1. So in switch 1, we will go to interface FA024 and we'll say switch port, trunk, native, and for example, 30. Native VLAN 30. Do show interface, just a moment. Do show interface trunk. And we may see that we configured our FA024 port on switch 1 as a native VLAN, selecting VLAN number 30. And immediately we saw that we have the message which is coming by the CDP protocol, Cisco Discovery Protocol, which is saying that that native VLAN mismatch discovered on Fast Ethernet FA024. So in saying that on our switch, the native VLAN is VLAN number 30, but on switch number 2, FA024 port, native VLAN is 1, and it will cause the problem. So that you will be sure that you will go to configure switch number 2 with the same configuration. Interface FA024, switch port, trunk, native VLAN 30. Do show VLAN. Do show interface trunk command will show you that this part is also configured as native VLAN. And now when your computers will try to make communication between each other, so let me take a look for the desktop and ARPA command, so that my computers will try to make communication between each other, like PC0 will try to make communication with PC10. First of all, oh sorry guys, first I had to go to the simulation mode so that ARP and D, ARPA, so no entry found here. So we'll try to make communication from PC0 to PC10, and as you see, ARP is generated right after the ICMP generated, because PC0 realized that it doesn't have the MAC address of PC10, and ARP is the broadcast, and it has to go by the FA04 port, and also it will go by the trunk port. And afterward, trunk realized that, switch 2 realized that this frame came from VLAN number 10, and it will resend it to FA01 and FA04 port, as you see. And then PC10 will give reply, and only afterward PC0 will send its ICMP message. Alright, this is how we can make the configuration of the VLANs, and this is how we can make the configuration of our trunk with the native VLAN. And now we can take a look for this ping communication one more time from PC0 to PC10. And when we are creating our frame, we can see here that our frame is looking like this. So we have our Ethernet 2 header with the source and MAC addresses, and when this frame will go to switch 1 and when it will exit switch 1, we'll capture it. We will see here that our frame have to be a little bit changed with the, so its header is going to be changed because it is now Ethernet 802.1q port. I mean the frame, and in this frame we have some changes. The changes is that we have this TP-ID, TCI type, and we have our VLAN ID. So if we'll take a look for the theoretical part with you, what kind of information do we have in target frame? As you see in target frame, so you see here, this is additional field tag in which we have type, which is defining that this is the Ethernet frame. We have the priority, which is consists of 3 bits. Priority is used by the quality of service. We have the canonical format identifier in case if we are using the token ring over the Ethernet. And the very important information is the VLAN ID, VID, which consists of 12 bits. And as you see, our frame is changed here, okay, because it is target and it is communication of VLAN 10. But let us try to make communication from laptop 0 to laptop 10. And as you know, so they are working on VLAN 30, and due to that fact that they are working on VLAN 30, our frames doesn't have to be target, on the trunk, because VLAN 30 is the native VLAN. Firstly, we have the broadcast, then we have reply of the broadcast, and then we have an ICMP. So firstly, we'll capture our ICMP. We may see here this is just an Ethernet 2 type of the frame, and then our frame is going to be traveling to another switch. And when we look for the frame information, when we capture our frame, we may see that here we have absolutely same frame format. It is not changed due to that fact that it is not target. So that when on target frame came to switch 2 understand that this is the frame which is coming from VLAN 30, due to that fact that we configured our interface with the native VLAN 30. Our next topic is the inter-VLAN routing. It's going to be the second part of this lesson.